Good morning, all of you. Today we will see third chapter of electrical instrument. Electrical instrument is nothing but the instrument which we are measuring on multimeter, DC voltmeter, DC millimeter, and so on. Nowadays, we are analyzing the circuit of instrument which is done with the measurement of basic three electrical quantities, which is voltage, current, and resistance. There are many more there are many more instrument which are cheaper and costly to buy, such as VTVM and CRO, etc. In this chapter we will study simple method of how to measure the instrument by different multimeter, such as DC voltmeter, DC millimeter, etc. Now we will see what is multimeter. Okay, multimeter is the one of the most important instrument which is used in electrical instrument. Multimeter is a multi-purpose instrument which is used as a single unit and a single movement and a single scale. Single scale has volt, ohm and millimeter, ohms and millimeter. Okay, voltmeter means, now see, volt means it is nothing but used to measure the voltage of two input. Ohmometer means which is used to measure or determine the resistance. Millimeter means which is used to measuring the current. One multimeter is also a combination of DC millimeter, DC voltmeter, DC ohmometer with a multi-range facility and an output meter. When we are designing an internal circuit, that time we should select an electrical quantity of a desired range. By selecting a proper range, we can measure the desired quantity accurately. In some multimeter function, switch is used, and some multimeter the inserting probe type arrangement is done to connect the meter for measurement. Now we will see practically how the multimeter looks. And what are the functions on the multimeter and how it display the values by different. It is a off condition. Okay, it is an off condition. Here the value we are getting of different stages on the display. It is an off condition. It is an AC signal. We are getting the symbol which is given here. It is AC signal. The value which can we take the value minimum to maximum 200 to 750 volt. It is a DC emitter. DC emitter here, which a value which we can measure from 200 milli to 2000 micro. If the current we should measure more than the 200, that time we should connect the probe, red probe to 10 emitter. It is a continuity. When we checking the continuity, the transistor resistor are checking on the continuity. It is a section of resistor to determine the resistor value from 200 to 2000 K. It is a DC voltage 200 milli to 1000 volt. It is a switch rotator at different stage we are rotating. This is a black probe which is used on multimeter, which is a common pin to multimeter. It is a red probe which is connected to volt, ohms, milliammeter. We can measure on this knob which is connected to volt, ohms, milliammeter. When we want to measure the current more than 200 milliampere, that time we should connect this red probe to 10 ammeter. Okay, now multimeter function is all. We have explained what we should measure on the multimeter: AC voltage, DC voltage, DC meter, and resistor to determine current we should measuring by milliammeter, etc. Second point, we will see D'Arsonval movement. D'Arsonval movement is the name of scientist which we known as PMMC. By word we understand is permanent magnet moving coil. Permanent magnet moving coil. Second, iron van type. Third is electrodynamometer type, but most of the multimeter use the PMMC, which is permanent magnet moving coil. Now we'll see the diagram of D'arsonval movement. By the diagram, we will explain the construction and working of D'arsonval movement. These both are the two poles at the both the end. This is a fixed iron core. This is nothing but a coil. The permanent magnet is the torque which is produced on the coil. It is nothing but a scale which increase at different stages. Okay, there is a torque. It is a pointer which we are measuring at different point the torque due to current we are checking. Okay, now we will see the construction of D'arsonval movement. The figure shows the construction of movement of D'arsonval, which is a name given of scientists, which is known as the PMMC. By word we understand it is a permanent magnet moving coil. It consists of a soft iron core, which means a fixed iron core, which is connected or mounted on a bearing. Okay, between the two poles of the permanent magnet. The coil which is suspended, this is a coil which is suspended, rotating freely in the magnetic field. The aluminium pointer which is given is one at the top and one at the bottom, which is in the bearing. This two spring is used for two purposes. First, which is used to provide the part for the coil to reach the current through the coil. Second, which is when the current is zero, then they pointer at the lower end of the scale and they provide a restoring torque when current flows to the coil. The iron core, which is nothing but a fixed iron core, is used to help to make a fill radle which ensure the uniform throughout the coil. When the current is passing through the coil, that time the magnetic flux is produced. The flux which is produced, which is produced by the permanent magnet. A torque is produced on the coil which is nothing but a deflection torque. The torque which is produced on the coil, it is nothing but a deflection torque, which result in the deflection of the coil which is getting by the pointer. As the pointer increases, deflection of the torque which is going on the coil is also increases. As the coil rotates, the restoring force caused by the spring. As the coil rotates, the restoring force which is caused by the spring which is rotating is also increases. The coil stop its deflection at a pointer. The coil started deflection at a pointer where the deflection torque is equal to the restoring torque. The deflection produced is proportional to the amount of current passing to the coil. The D'Arsonval movement is also known as D'Arsonval movement is specified in terms of current, sensitivity and internal resistance. A typical movement having 100 microampere full scale deflection. As IFSD equal to 0.1 millimeter, internal resistance Rm is equal to 500 ohms. IFSD is maximum current which is required for full scale deflection. As today we have completed the first point as a multimeter. After that, in next lecture we will see basic millimeter and the derivation and multi-range millimeter. Thank you.